Okay, so if neither the A values or the B values are opposites of each other or are the same, two situations we've had so far, then we need to rename one of them by multiplying to create our opposites. Again, we're always trying to create opposites. That's still the main goal. So those opposites aren't there, but we have the same x's or the same y's, then we can multiply by -1. But if we don't have these same x's or the same y's, then we're going to rename one of them by multiplying, and this time it's not going to be by -1. We're going to have to pick another number to multiply by, okay? So we have our system of equations, 3x plus 6y equals 12, negative x plus 3y equals 6. We would create opposite for the A values if we multiply the second equation by what? 3. Because the opposite of 3 is -3. So if we took negative x times 3, wouldn't we have a negative 3x? So just like we did when we multiplied by the -1, yes, we have to take every piece of the equation.
This is what I was talking about yesterday for some odd reason.
Times 3. So every piece has to get multiplied by 3. So we're doing it 3 times because there are 3 pieces to this equation. So what's our new name for that second equation? Negative 3x plus 9y
18
equals 18. Well, once we've renamed one of the equations, we don't want to add it back to its old self. We want to add it to the other equation. We have to add that to the other equation, which in this case, in our case, it happens to be the first equation this time, because we renamed the second equation. So we're going to set up our addition problem. We have our first equation is 3x plus 6y equals 12. Our new named equation is negative 3x plus 9y equals 18. And of course, I don't have to walk you through the steps of this. You can go ahead and do it, and we'll see if we all end up with the same y value, because these are going to cancel out. What's y equal? Chelsea? 2. Okay, there's our y value. And we always like it when it turns out to be an integer, don't we? We're feeling pretty safe that it might be right then. By the way, do they have to be integers? Do you have to get an integer answer? No. Okay, it's just that I've been nice to you and I've given you equations where you do get integer answers, right? Okay. So now it says use either equation to solve for x. Okay, so we are going to go back up to the beginning and see which one do we want to use for solving for x. And if you've already picked yours and started it, fine. The rest of us, which one should we use? I think I'll use the second one. You want to use the second one with me? No, because it's got a negative in it. You want to use the first one because it's all positives? Okay, that's always a good choice. All positives to work with. 3x plus 6y equals 12, right? Okay. So we'll solve our y value in. What am I going to do? I got a 0.
Still divide by 3.
Oh, I still divide by 0. There's no panic just because a 0 shows up in the problem. You just keep going, right? So, what's our x value?
0.
What is 0 divided by 3?
0.
0. Can we have 0 for a solution for x? Is it okay?
Yeah.
Yeah, it is. So what's our ordered pair solution?
0, 2.
0, 2. Okay. For a opportunity to get to actually go to lunch today and not have to sit in here with me instead, tell me, what did we just find? What does this really say, Haley? Where the two lines intersect on the graph? Where do they intersect then?
0, 2.
At ordered pair 0, 2. By the way, where is that on the graph? Where is ordered pair 0, 2? Quadrant 1, quadrant 2, quadrant 3, or quadrant 4?
Neither.
Yeah, none of them.
None of them, because it's where?
It's on the axis.
It's on the y-axis, isn't it? This is like a y-intercept. Oh, well, if it's a y-intercept, then it's probably the y-intercept for both equations, because they got to cross at that, don't they? Okay. Okay, any questions? Okay, then let's go and decide. Now, when we look at this one, we see that we have a 3x and a 2x. Can you multiply just one of them by something and rename to get nice? I mean, you can, but is it going to be pretty? What's the opposite of 3?
-3.
-3. What would we have to multiply 2 by to get -3? Do you like to even think about it? Do you even want to think about that?
Okay, well,
What?
you have to change add the opposite first.
Okay, you want to do add the opposite first.
I just have to.
That's exactly why the arrow is there. 3x plus -4y equals 7, and 2x plus -1y equals 3.
And then you times the bottom one by -4, and then you get a +4, and then they cancel out. I already did this. I already had a focus.
Okay, so I'm kind of walking you through the process, so how are you going to decide? So you got 3x and you got 2x, and you say to yourself the opposite of 3 is -3. I'd have to multiply 2 by what to get -3? Oh, I don't want to deal with that. That doesn't sound like much fun. So then you go over to the y's, and you say the opposite of -4 is, help me, or 4. And then you say, oh, what would I have to multiply -1 by to get 4? To get +4, I'd have to multiply by a -4. So we're going to multiply every piece of which equation?
Bottom one.
The bottom equation. So we're going to take the -4 times the 2x. We're going to take the -4 times the -1y, and we're going to take the -4 times 3. And if after you're done renaming it, it doesn't, what you needed to happen didn't happen, then you're going to go back and take care of that before you can keep going. So what does happen here is we end up with a -8x, we end up with a +4y, and we end up with a -12. I don't know if you remember this, but last spring, here's where you commonly made your mistakes in these problems. You forgot to multiply the number on the other side of the equation. You left the 3 out, and you didn't do that, and you'd be like, I don't know where I went wrong. And typically, when I would come to help you, it would be because you forgot to do the multiplying over on the other side, too. Okay, so now we say, if we add this to 3x plus -4y equals 7. Okay, so you got this all lined up and you look at it and what better happen? Otherwise, don't even proceed. What better happen at this point when you look at it?
Mine's flipped around.
Okay, that doesn't matter. So you have this one on the top and that one on the bottom?
Yeah.
Okay, what better happen though before you even proceed? And you better have opposites. You better look and make sure that you have some opposites like we do right here. So we get to say, okay, I can proceed because these guys are going to take care of each other. So I now have, what's 3x plus -8x? -5x. What's 7 take away 12?
-5.
-5. Jossie's got the finger, stuff going on her way. She's helping me out this way. Saving on her voice. Okay, what do we do to both sides of the equation now, Brian?
Divide by -5.
Divide by -5. And x is equal to 1. Okay. Which equation do you like better for solving for y?
The top one.
Top one? Okay. So the top one is our 3x plus negative 4y equals 7, right? Is that the one we're going to use? So we're going to put 1 in for x and solve it for y. Okay, get your y value. It's a fraction this time.
What?
For you people who were dead, I just had to, see if you were alert.
I was gonna say I did it twice.
I don't say this is not a fraction. Really, when I mess up, I get a fraction. This time I did it right.
Yeah. Don't tell me that, I was supposed to get a fraction when I finally think I did it right. What does y equal? Negative 1. Negative 1. Okay, I have a question for you.
I have an answer for you.
Good.
Maybe.
What's
Probably
the
not.
solution?
1, 1. Or 1, negative 1.
1, negative 1. Okay,
Answer.
I
so,
have a question for you. Why are you recording this?
oh, it's for, like, maybe like Alexis, who isn't here, she would have the opportunity then to, okay?
Wait, does that record what we say too?
Just what we're saying, doesn't record our what we look like, so.
I have a question.
Sorry about that.
Can you go up real quick? Can you go up real quick?
Can I go up real quick?
Yeah.
Sure. How far do you want me to go up?
Okay. That's
Okay. I have a question for you. What if this is the only question on the test next week?
What?
Yes.
Just one question test?
Careful, careful. Just listen to me. What if this is the only question on the test next week, and the new eligibility policy, and maybe even your parents might not be very happy, but this is the only question on the test, and if you don't get it completely right, I give you a 0. Or if you get it right, then you get 100%. Those are your only choices. A 0% or 100%.
Okay.
Now, you can't be failing any classes, to be in any extracurricular things. And then your parents might have some rules for you besides. How would you, not just the fact that we got integer coordinates, we got integer x values and integer y values, how else would you want to make sure that you had the right solution? Do you have any idea how you could verify? Because you're like, I'm not taking the chance of getting a 0 on this test. So what could you do? What's one thing you could do? Cassidy, what's one of them?
You can plug your x coordinate that you got, plug it in for the x separation equation.
Okay. So you can put the x coordinate that you got into
For x.
into where?
Put it into the linear equation.
Just one of the equations?
Both of them.
It has to check out in both of them, doesn't it? But while you put the x in, what else do you have to put in?
The y.
You also got to put the y in because the x and the y together have to make both equations true. Yeah, it has to work in both of them, doesn't it? So that would be one way. What's another way you could do it, Haley? You could graph it. You could say, can I have a piece of graph paper, Mrs. Brown? I want to check to make sure I have this right. You could graph it, and what should happen?
cross it.
They should cross at that point. And if they do, then you might be feeling like, okay, I'm ready to hand this in the basket and hope for the best. Okay, so in other words, we got to know how to make sure we have the right answer also.